Good morning, everyone. It's a great honor and a privilege to be here at AIFC, part of your EdTech forum. I greatly enjoyed the talks in the morning session, as I'm sure you all have. My talk is going to be about leveraging machine learning for data-driven decision making. So let's get started. So how many of you have, so a quick background about me. So I was born and raised in India, and I've been working at the intersection of machine learning and large-scale software systems for about 10 years now. Most recently, I'm a technical lead at the cloud AI platform at Google, and what we help with the help of my team, what we do is we try to help businesses in their AI transformation journey. So we try to make sense of how they can make use of their existing data, how they can make use of their existing people, and how they can make use of the new technologies to do more than what they're doing today. So that's a brief background about me. What I'm going to talk today is going to be about three things. I'm going to do a quick introduction to AI and ML. What do these things mean? What is artificial intelligence? What is machine learning? How do we define these in the context of what we're going to talk about? The second part of my talk is going to be about how AI can be used, how AI is transforming enterprises and businesses, how it's helping them in their digital transformation. That sets the context for how AI is enabling all of these businesses to do more. And the third part of my talk is directed more towards the students or towards the people who want to be involved in this process. I'm going to be putting on the hat of a practitioner, of an ML practitioner, and I'm going to go into the details of how you do things, how you make decisions based on the ML mindset as opposed to the traditional mindset. So those are the three things I'm going to talk about. Let's get started with the first one, AI and ML. So AI is obviously artificial intelligence, ML is machine learning, but what are these two? These terms are often used interchangeably. Many people say, ML is the same thing as AI. Many people, so this is a quote by Paul Doherty, who's the CTO of Accenture, and what I wanted to highlight through this slide is that AI everybody knows that AI, everybody sees the potential of AI in transforming businesses, but what really is AI? Here's one way of putting things into context. AI is the science of making things smart, right? How do you bridge the gap between machines and humans? And machine learning is the science of, is about making machines use data to get smarter, right? Teaching machines how to be smarter. So the way I would put this in context is ML is a way to achieve AI. ML is a way to achieve AI. Machine learning is a way to achieve artificial intelligence. And so that's a subtle distinction. ML is a technique, whereas AI is a general science of how to be smarter. There are many ways to do AI. ML is just one of them. Here is a quick example. I'm sure all of you have used email. All of you have used Gmail. And back in the days when I started my career, we used to do spam in the old way. We used to do it in a mathematical way, in an analytical and a logical way. We would think about how to solve spam. What is spam? How do you determine what is spam and what is not spam? And we come up with rules and heuristics and algorithms to figure out, solve the problem, and then implement it in code, right? So that was the old way of doing things. And the new way, over the last decade, the new way of doing the same problem, the spam classification problem, the new way to do it is to teach a machine to solve the problem in a naive way, not a very efficient way, solve it in a naive way, collect more data, try and learn from the data how to improve itself, and repeat this, rinse and repeat until it beats the older way of doing things and starts getting even better and better and better. Right? So there's a slight distinction. The old way was about analytical, mathematical modeling of the problem. The new way is like teaching a child. The way you teach a child about how to solve the problem, how do you collect more data, how do you improve that. So it's more of a natural science than an analytical, mathematical science from the point of view of a practitioner. Right, so that was a quick overview, quick introduction of what AI and ML is and how the new way of doing things is different from the old way of doing things. Going to the next part of the talk, let's look at how AI is powering the transformation of enterprises. With this slide, I want to illustrate that AI, every company is talking about AI and machine learning. The blue and the red lines in the graph show you that the earnings call of IT companies on the left and all the other companies on the right, you can see that everyone is increasingly talking about AI and ML. And so that indicates that there's a promise. People see that there's a promise in applying AI and ML to their businesses. But when businesses actually talk about AI, the kinds of things you hear about are things like proof of concept, feasibility study, A/B testing, pilot studies. What that indicates is that companies aren't really leveraging the full power of AI. They're really hesitant to deploy AI in production in their systems. The main challenge here is the risk and the disruption that comes with applying ML and AI. It's a process change. The way businesses do things undergoes a drastic change in the DNA of the way the business works, and this is very risky. And as a result of this risk, people are fearful of applying new things. And so that is what is reflected here. The promise, which is the research, the advancement in the research has outpaced even the Moore's law, but the reality is that only 12% of enterprises have deployed AI in production, right? So that's the challenge, and that's what we see in front of us. And so what's going to happen over the next 5 years or so, 2019 to 2025 plus, is that we're going to have new builders who will have the mission of empowering every enterprise to transform their businesses with AI. Right, so you're going to have deep learning researchers, you're going to have AI experts, you're going to have developers, you're going to have business users, you're going to have data scientists, you're going to have data engineers. All of these are the builders who will enter the workforce over the next decade or so. And their mission will be to bridge that gap between the promise of AI and the reality that only 12% of businesses are using AI in their production. Right? So with that mission comes challenges. The enterprise challenge is, how do you get the most of the data with your existing infrastructure and people? Today, businesses have an existing employee base. They have existing data, and they have existing infrastructure in place already. They can't just change all of that overnight. We have to meet them where they are, and how can we empower them to do more with what they already have, rather than getting them to transform the way they do their businesses? So that's going to be the first challenge. And of course, the way we're going to address that challenge is through all of these builders. These are the skills that will come into the workforce, and these are the people who will help businesses transform the way they do their businesses. ML engineer, data engineer, developers, data scientists, business analysts, and finally the end user. Collaboration between all of these users and all of their skill sets is what's going to enable bridging this gap. In addition to enterprise challenges, we also have technical challenges. So the technical challenges are, around data, around workflows, around flexibility, and around collaboration. And these represent limits in the technologies that are available in businesses today. So for example, how do you get data? How do you ingest data efficiently? How do you do your computations efficiently? How do you make sense of that data? How do you automate and run all of these things in production? What kinds of workflows do you want to use? The old workflows don't work. The new workflows will need to be adaptive to all of these businesses. By flexibility, what I mean is that a lot of businesses have on-premise infrastructure, which means their own server stack. And in the future, they might want to move to the cloud. And all of this is a very complicated process. We want to build tools so that all of this happens without affecting the day-to-day business operations. And finally, how do you collaborate with users? I've heard case studies where within the same business, different groups of people are solving the same problem again and again. One group of person, solves the revenue forecast problem using some data that they have, and another group within the same company is trying to solve the same thing, but they don't know that the other group has already solved it. So how do you bridge this gap where knowledge can be shared even within an enterprise and even outside the enterprise? So how do you bridge that gap? So these are some of the technical challenges that are involved in this digital transformation that's taking place. Another way to look at this is that ML is just a small piece of the system of components that need to be introduced into the technical infrastructure that these businesses are using. You need data verification, you need monitoring, you need productionization, you need analysis tools, you need all of these things that go along with just your ML code. And so it's not just an intelligent data scientist solving the problem for you, but it's an ecosystem of things that come together to solve this problem for you. And that also represents a technical challenge. How do you transform businesses to understand this? This will change the process, the way they do their businesses. So that's those were a few of the things. So that's how AI is transforming businesses. That's how those are the kinds of enterprise challenges and the kind of technical challenges that businesses are facing. And that's the kind of context under which all of the new builders will come into the workforce and will help them solve this journey that the businesses are on. Okay, so the third and final part of my talk is wearing the hat of an ML practitioner and going through how you use ML for decision making in businesses. So the first part, when you want to think about a problem that you're solving in a business, is how do you frame the problem as an ML problem, right? So let's say you're an employee in a business, or you're running a business, and the problem you're solving is, which product should I stock in my store, right? You have a choice of 2 products. Which of these 2 products should I stock in my store? So that's your articulation of your problem. You want to choose between 2 products. You have a classification system. You want to choose between one product and the other, and you want to quantify that decision. Which one should you choose? What are the benefits of choosing one versus the other? The second step that you want to think about is you want to find out if there's any data that can help you that can help you assess that decision. Do you have examples from other businesses that are using one product versus another product? Can you get details on how much sales occurred on those products, how much revenue occurred from those products, and so on? Third step would be to design your data, how to figure out what data is useful, what data is not useful. Fourth step, determine where to get that data. Once you've figured out what data is useful, where can you get it from? Determine the inputs and the outputs, quantifiable inputs and outputs. And I'll go into some of these details with examples in the next slides. When you look at ML, typically all ML problems fall into one of these 6 categories. So you have classification, you have regression, you have clustering. Classification is basically classifying between one of n different categories. So imagine if you have a picture, you want to classify whether this is a picture of a dog, a cat, or whatever. That's an example of classification. Regression is a kind of problem where you're predicting a numerical output. You're estimating the revenue forecast or a click-through rate of an advertisement, or something, or a specific probability associated with a certain event. So those numerical problems fall into the category of regression. Clustering is about grouping similar items together. Association rule learning is about finding patterns in data that can help you understand that data better. So if you throw a bunch of data, you can realize that when this happens, when certain events happen, this is the outcome that's associated with that event. And such kind of rules can be learned from unsupervised learning on data, and that's what association rule learning is really about. The fifth type of ML problem is a structured output problem. This is a problem where you create a complex output, typically a vocabulary. An example of this would be document understanding. You want to go through documents and understand what this document is about and input that into the system. That's structured output. And finally, the last kind of problem that most ML problems fall into is ranking. Ranking is where you rank a set of items in order of some relevance, where the most relevant item is at the top and the least relevant item is at the bottom. Let's talk about 3 sophisticated ML applications. The first one is Smart Reply. So I'm pretty sure all of you have used Gmail. When you get an email on Gmail and when you hit reply, one of the things you must have noticed is you get a prompt at the bottom which gives you 3 suggested responses to select from when you frame your response. That's an example of a sequence-to-sequence learning problem. It's an example of the structured output problem, which I talked about earlier. The second problem is a YouTube Watch Next. This is about recommending YouTube videos. When you watch a certain video on YouTube, you want to rank the set of videos that the user wants to watch next after having watched this video. So that's a ranking problem. And the third problem is actually an interesting problem from a farmer called Makoto in Japan, who actually built a cucumber sorter using TensorFlow. What he did was he realized that sorting cucumbers by hand is tiresome, and it takes a lot of time and energy by people to sort things into different categories. So he built an algorithm to sort cucumbers by size, shape, and color, and it's able to achieve more than 95% accuracy, and it saves them a lot of cost, and it drives up efficiency in the way they do businesses. And this is an example of a classification problem. It's a multi-class classification problem. And so here are the 3, so these are the three deep dives. Let's take a look at the ML problem framing, which I talked about earlier, and let's see what exact problems are these trying to solve. So Smart Reply is trying to solve the problem that responding to emails are time, they consume a lot of time, and you want to make it efficient for users to respond to email. That's the problem. What's the output of the ML algorithm for Smart Replies? The output of the problem is a short list of 3 suggested phrases, right, that the user can choose from. And what's the input? The input is the conversation data, the emails and responses from all the users that have used Gmail, right? So that's the input. So now you have all the ingredients for the ML system. You want to teach the ML system, you have the inputs, you need the ML system to produce this output, and you want to solve that problem. And so you have all the ingredients to start training the system to start improving on that problem and get better and better with time. The second one is YouTube Watch Next. What's the problem here? There are too many videos on YouTube for a person to find what they like. There are billions of videos there. It's really hard to find out what is it that you're going to be interested in as a user. So that's the problem. You want to find the needle in the haystack that the user is interested in. The output is a suggested list of videos on the right side of the screen. And what's the input? The input is all the data you have about users on YouTube. You have watch times of videos, how long did people watch different videos, the click-through rate on the different suggestions you have made, the search history of users, the watch history of users, and all of that is the data that goes into the system. So again, you have the input, you have the output that you need to show, and you have the problem or the metric that needs to improve. And you can teach a system, teach an ML system to first solve this problem naively, collect more data, and get better over time to solve this problem better and better until it's acceptable, and then even better than acceptable. The third one is the cucumber sorting problem, and the problem here is simple. The manual cucumber sorting is burdensome and slow. The output is directions to a robot arm to sort the cucumber by categories. And the input is labeled examples. You go to the experts and you ask them to label the different types of cucumbers, and that's your inputs that are fed into the system. So you have inputs, you have the outputs, and you have the problem or the metric that you want to solve. And now you have the ingredients that you can put into the system to start improving on solving this problem. So this slide was about taking 3 problems, putting it into that framework of the ML framework that I talked about earlier, and looking at how specifically these things map to the items in that framework. Now let's get into the task of the ML algorithm itself, the ML process itself. How do you go about solving it? Okay, you have inputs, you have outputs, you have the problem. Now what do you do? And this alludes to the slide that I talked about spam classification earlier. The ML way of solving problems is more like a natural science. It's not really a mathematical or logical way of looking at things. It's not about solving the problem itself. It's about how to teach someone to solve the problem, how to teach a child to do this problem, right? So that's the shift in mindset that needs to occur when you wear the hat of an ML practitioner. And this is echoed by the quote here by Peter Norvig, who is the research director at Google as well. And there's a funny XKCD clip where you can see that the joke is that you just it's not about understanding the data, it's about moving the data around until you get the right results that you want to get, and you make sure that it's verifiable and repeatable. So that's the change in mindset, solving the problems the new way, the machine learned way. But digging into it, it involves these various steps. So this is what I call the ML mindset. The ML mindset involves these six steps. The first step is you want to set the research goal. What is it that you want to do? For this example, I've taken a goal of trying to predict traffic. When will traffic be heavy on the roads, right? That's your research goal. The first step after that goal is to make a hypothesis, right? So maybe weather forecast is a useful system. Maybe you have an idea that maybe when it rains, people are going out in their cars instead of taking public transport, and maybe traffic is higher when it rains. So that's a hypothesis, right? The next step you want to do is collect data that is relevant to that hypothesis. What data is relevant to your hypothesis? The weather forecast data, the historical weather data, and the historical traffic data, right? So you want to collect historical traffic data, and you want to collect historical weather data on each day, right? Then what you want to do is test your hypothesis. Test the hypothesis whether traffic is really correlated with weather or not. Once you test your hypothesis, you want to analyze the results. Once you analyze the results, you reach a conclusion whether or not the hypothesis is true or not. And if it is true, you say that, yes, this is true, let's go and refine and improve on it. Or if you say it's not true, you reject it, and you say we reject it because of X, Y, and Z reasons. And this is really a loop. You reach the conclusion, you make new hypotheses, and you iterate on this until you're able to achieve your research goal at the very beginning. So that is what's involved in the ML mindset, the way of approaching things through ML. Finally, I want to make this slide is about not all problems are a good fit for ML. Rather than looking at ML as a way to solve every kind of problem, you want to ask the question, is ML a good fit for this problem, right? And the way you want to do that is whenever you have a problem to solve, you ask the 2 questions. What problem is my product facing? What problem are you trying to solve? And would it be a good fit for ML? And you want to ask these questions in this order, not the other way around. Otherwise, you fall into the trap of using ML where it's not really useful, right? Know the problem before focusing on data, and focus on features which have predictive power based on hypotheses instead of throwing all the data at the algorithm, right? One example I like to use is if you throw irrelevant data, garbage in produces garbage out. So if you throw in irrelevant data into the system, you're not going to get meaningful causal correlations out. You're going to get junk correlations, and you'll have trouble understanding what that means. And the final point is aim to make decisions, not just predictions. And this is a very crucial point. You're trying to make decisions with the help of ML algorithms. You're not just trying to predict what's going to happen. You're trying to make decisions on what you should do. And there's a difference between these two. And so I've put in some examples here. YouTube Watch Next. For YouTube Watch Next, for example, the prediction is which video would the user watch next, but the decision you're making is which 10 videos to show on the right-hand side bar to the user. These are two different problems. Of course, the first one is useful in solving the second problem, but the first one is not the goal by itself. The second one is the decision that you're making. Same thing for the second one. The probability that the user will click a given search result, that's a nice problem to solve, but the real decision you're doing is whether you should prefetch the web page or not, and that depends on the input of the previous model. And so, in general, you want to focus on decisions, not just predictions, and that's the final takeaway from this slide. So as a recap, what I've talked about is quickly defining what AI and ML means, how AI and ML is transforming enterprises, how it's helping them in their digital transformation journey. And the third part of my talk was about the mindset of an ML practitioner and how you should approach problems compared to the old way of approaching problems. I hope that was useful to all of you who might want to help this journey in your businesses, in your companies, in your enterprises, and so on. And I'm excited to learn more about what you're working on, and what kinds of challenges you're facing, and what kinds of solutions you've come up with. Thank you.